Hello. In this video, I would like to share with you how to graph trigonometric functions. The sine, cosine, and tangent functions are periodic functions, or functions that repeat after a certain interval. These functions can be used to describe many real-world events whose behaviors repeat. Before we see the applications, it is important to cover the basics. Let's start with a table of data. In order to graph these functions, we will let the angle measure, or theta, represent the independent variable along the horizontal axis of our graph, and the result from the trig function will be plotted along the vertical axis. While the scale between radian measures and degree measures are different, the shape produced by the trig functions would be the same for each. For that reason, we have the radian measure and the degree measure listed at the top of the table. Completing this table can be done with a calculator or by recalling the coordinates of the corresponding angle measures inside a unit circle. The sine function result for each angle measure is simply the y component of the coordinate corresponding with the angle measure. The cosine function is the x component, and the tangent function result is the y component divided by the x component. Even with the coordinates memorized, it is helpful to determine the decimal value of each since it will be easier to graph them. Here's a completed section of the table. You can see I indicated the component results from the unit circle, and I showed the decimal equivalent accurate to 2 decimal places. Please pause the video now to complete the rest of the table. Resume playback in a moment to check your work. Hopefully you noticed patterns start to develop while completing the table. Also, you should have noticed that a few of the tangent values were fractions that contained 0 in the denominator, which leads to an undefined result. You'll see how that affects the graph in just a moment. By starting with the sine function, we will see the cyclical pattern create a distinct shape. With an x-coordinate of 0, the y-coordinate would be 0 as well. At 30 degrees, or pi over 6 radians, the y-coordinate is 1/2. At 45 degrees, or pi over 4 radians, the y-coordinate is the square root of 2 divided by 2, or 0.71. At 60 degrees, or pi over 3 radians, the y-coordinate is the square root of 3 divided by 2, or 0.87. At 90 degrees, or pi over 2 radians, the y-coordinate is 1. At 120 degrees, or 2 pi over 3 radians, the y-coordinate is again the square root of 3 divided by 2. You may have noticed a wave start to form and that we have reached a peak and we're starting to decline. If you continue plotting points of the sine function, it would look like this. The full cycle of the wave, or period, completes after 360 degrees, or 2 pi radians. It would then repeat indefinitely to the right and left. Please use the coordinates from above to plot the cosine function. You will find a striking similarity between it and the sine function. Pause the video now and resume playback in a moment to check your work. As it turns out, the cosine function is the exact same shape as the sine wave, only shifted horizontally. When plotting the tangent function, most coordinates are located using the same technique as before. However, at 90 and 270 degrees, the function is undefined. This disrupts the wave that you might think you see forming, and instead creates vertical asymptotes. These segments, or branches as they're sometimes called, repeat every 180 degrees, or 1 pi radians. I would encourage you to try plotting these functions on another set of axes, this time with the horizontal scale in radians. If you have trouble locating multiples of pi, try using a calculator to identify the positions of these key data points in decimal values. Completing this exercise will help you understand that the shape of the graphs are the same regardless of the type of angle measure, degree or radian, but they may appear different due to their scale. Good luck!